Okay, sanibonani guys. Lana sizobe sibheke a question on ama equations of motions. Alright. Laga grade 10 we talk about ama equations of motions. Bang the Q10. Man. Grade 10. Laga grade 10, G10 baba. Kuna ama equations of motions. Yes, equations of motion. Grade 12 ngiyamskipa grade 11 ngoba aswasebenzisi. Is there? No, aswasebenzisi. Maybe ku Newton's law, maybe ngawasebenzisa, but no. Then ka grade 12 you enter something called a vertical projectile motion. Vertical projectile motion uyosebenzisa the exact same equations owafundayo manje this year. Ka grade 12 uyenza I vertical projectile motion. Bheka ke now. Bheka ke la. This is the action la ku question 3. Car A is driving at approaches a stationary car B. The driver of car B noticed that car A is approaching him at a very high speed. Mhlambe ubuhlabile or mhlambe high on something. Then uyinyathelile vele uyabona. Then the driver of car B reacted suddenly by accelerating his car from rest at uyisusa from rest to accelerator for 11.5 seconds, and after 11.5 seconds car B continued driving with A ayiphelelanga le question. Anyway asibona ukuthi basibuza ama question anjani ke la, right? So car A uyambona na isibayibayi semoto yini, it looks like a Porsche or something. Then I Jeep le yabona uyinyathelile mfana. Lokhu ola ku car A uyinyathelile, then ku car B lo muntu ola ku car B wabo ukuthi hayi no la bazongimoshela imoto la athi ngibaleke nami uyabona. Alright, ku 3.1 bathi convert 135 km per hour to meter per second. Alright, so sino 135 km per hour sifuna ukuyichange to ama meters per second, right? So what do we do here? We divide by 3.6. Nas divide ngo 3.6. 135 divided by 3.6. Answer it's 37.5. 37.5 meters per second. So what if bofuna convert from ama meters to ama kilometers? If that's the case, you multiply by the same 3.6. So ungayikhohlwa le value le. Ungazithola so divide ngo 2.6. No. It's 3.6. From kilometer to meter per second, 3 divided by 3.6. From meter per second to kilometer per hour, you multiply by 3.6. 3.2. But it determine the velocity of car B while trying to avoid car A, right? So basibuza ngo car B, right? They are asking us about car B. There's data about car B. There's also data about car A. Is keep up on my what? Okay. Car B. Okay, car B is the acceleration. Acceleration is equal to 1.5 meter per second squared. I think ngizoceda space ngale. I think sondezelo A la. A is equal to acceleration meter per second squared. Oh, by the way, ama units lawo acceleration, it's meter per second squared. Ungayibhala as meter dot s raised to exponent minus 2, or ungayibhala as m per second squared. Ne? So ungabi confused nangabe ngisebenzisa lelo kanje le. Uma ngabe sengibhala ama units ngeindlela. Alright. Bese basipha nesikhathi delta t 11.5 seconds, and she accelerator for 11.5 seconds, right? And the car was stationary, meaning that the initial velocity was 0 meter per second. 0 meters per second, right? Now sifuna ini the velocity of car B while trying to avoid car A, meaning that is our final velocity. It's unknown, sifuna calculate yon, right? Then you go to consult ama equations of motions. I4 1 2 3 4 wathola ku formula sheet. Okay, sifuna a formula a nalama quantities law: acceleration, time, initial velocity, final velocity. Yiphi la? Asibheke ku equation 1, sine final velocity check, sine initial velocity check, sine acceleration check, sine delta time, delta t check. So equation 1 uyesomsebenzisa. There's no need to check lawa manye. Use this one. So tata final velocity equal to initial velocity plus a delta t equal to, what's our initial velocity? To 0, acceleration 1.5, delta t 11.5. So answer yethu uthi 0 plus 1.5 times 11.5. Answer 17.25 meters per second. So this is the speed azozama, velocity azozama ukuloka kanje ukuavoida ini, azozama ukuavoida le moto ka A. Sorry. But we also need to give it direction la ngoba the velocity is a vector quantity angisho. So nangu B singathi maybe to the east, right? I'm sure it's south, east, west. So yeah, to the east mhlambi izoyale phambili, right? Izoyale phambili 3.3. How far has car B driven after 11.5 seconds? In other words, basiphoza ukuthi i-travel i-distance engakanani, delta x. Sifuna ukwazi ukuthi delta x ubani ke this time, right? So uyofuna a formula eno acceleration, ino delta t, ino initial velocity, bese delta x unknown ke. Yiphi leyo formula? Asibone la delta x akekho, so angeke sisebenzise. Initial velocity, alright, ngifuna the one without a final velocity. Now delta x, now acceleration, now initial velocity, but there's final velocity. This one here, avoider, initial delta t, acceleration delta t. Okay, now equation is 3, this one. So sizoti delta x equal to v initial delta t plus 1/2 acceleration delta t squared. Guys, lana nayi advice ke, whenever ukhetha a formula out of lama equations of motion, it's a mark for writing down the formula. It's a mark for writing down this formula. Ne? Ungaveli uthi okay ngiyosebenzisa le formula le bese naso ubhala phansi ku script sakho awusabhali equation wena so ubhala so substitute uzoluza ama marks kanjalo, ne? Sizala sithi initial velocity 0, delta t 11.5 plus 1/2 acceleration ubani 1.5, delta t as 1.5, delta t 11.5 squared. We calculate again 0. In fact, last tolu 0 la. 0 times any number, it's 0. So let's calculate the last part. 1/2 1.5 11.5 squared. Answer 99, in 2 decimal places, 99,19 meters. This is the distance. It's a distance, so look, I scalar quantity distance here too, so there's no need for a direction. 3.4, bayabuya ke manje bathi the driver of car A suddenly hits the brakes, and managed to stop after 40 meters. What acceleration does car A experience to come to a standstill? Right, so bafuna ukuthi si calculate the acceleration as we experience, right? In fact, it's not called the acceleration, but it's what we call a deceleration, right? The moment we apply our brakes, we are decelerate. Now unyathela amafutha emotweni, there's something called the accelerator, thina sibiza ngokuthi amafutha. Now unyathela i-accelerator, imoto ya accelerate. Now unyathela i-brake, imoto ya decelerate again, ne? So now into engizoyenza ngizo erase this part kuphela. So siqedile ngokukhuluma ngocar A ke manje, ne? So sebasibuza ngocar B, ngocar A manje. Siqedile ngocar B. All right, so we have initial velocity. Now, si calculated, sathola ukuthi it's 37.5 meters per second. First question, angithi. Final velocity. The final velocity kuba ubani equal to 0. Remember, the car will come to a stop after 40 meters, meaning that is wenzani final velocity kwamele kuba ubani u0. The whole point of applying our brakes is just to stop the car, so the final velocity should be 0. Accelerate, okay, sifuni acceleration, the deceleration, right? Sifuna ukuyithola ukuthi ingakanani. What else do we have? We have delta x, which is the 40 meters, right? But so good, after 40 meters you stop le moto, so delta x ubani 40 meters. Now, out of the 4 equations of motion, which one are we going to use? Ngifuna the one in initial velocity, final acceleration, not delta x. I can apply this one. Nah, it's this one. Final, initial, blah blah blah. Nazo. Okay. 3,4. Let's see. Final velocity squared equal to initial velocity squared plus 2a delta x. Final velocity kuzoba 0. Initial velocity kuzoba 37.5 squared plus 2 acceleration unknown delta x 40. It's 40, so it's 0 squared, it's 0. 37.5 squared, 37.5 squared, answer ubani 1406.25 plus 2a times 40, it's going to be 80a transposal 1406.25 equal to 80a. Let's divide both sides by 80, therefore a uzoba equal to, divided by 80, the answer it should be negative 17,58 meters. Whoa, why? Whoa, why? Oh, meters per second squared. All right, something doesn't feel right. That's imbonela. Oh, Jesus. Oh, Nkosi yami. bheka ke la kanti lento iyasitha la kuno 4 seconds but what acceleration does car A experience to come to a standstill after 4 seconds? Now, this changes everything, manje. This changes everything. A mistake yamle, guys. I apologize. Ngifihle information la, but there's nothing wrong ngale step list. Just with the approach for this question ayikho appropriate. Why ngisho njalo? Now they bring in time to the mix. Sebaletha isikhathi to the mix. Now, there's one more data la. Delta T 4 seconds. Voila. voila. Sukuti bekwamele si calculate using this formula. Right? Initial check, delta T check, acceleration unknown check. What else? Delta X is given check. So for this one, final velocity angeke simsebenzise. Check this out again. Delta X equal to V initial plus V initial delta T plus 1/2 acceleration delta T. This approach ayikho wrong. Just kuti the only issue la ukuthi they gave us time. So we need to take that time into consideration. So the only formula is just allow ukuthi sisebenzise isikhathi. It's this formula. Even this one kumele isebenze this one. But anyway, siqhubeke la. Initial 37.5 delta T 4 plus 1/2 acceleration unknown bese delta T 4 squared la. So it's 40 equal to times 37.5 no 4 we get 37.5 sithola lo 150 plus siyabuya ke masithi 1/2 times 4 squared, that's 8. A alright, then sithi 40 minus 150 is equal to 8a, then it's total negative 110. 8a, divide both sides by 8, then city minus 11, 0 divided by 8, answer it's negative 13, a negative 13.75 meter per second. Meter per second squared, the acceleration. Therefore, a is equal to 13.75 meter per second squared. Deceleration, le uyabona umehluko okhona la, negative 13 late negative 17. It's because of this time. Nangaba kuphi isikhathi kwamele usebenzise, right? So ngaba ngisibonanga lesikhathi lesi, ngabe this whole thing iba wrong because of we didn't use time in our calculation. So question 3 izophelela lana, guys. I hope uthole something. I hope you learned something. Applying ama equations of motion, it's not that difficult. You just need to take out the data, then check out the information or ama quantities onawo against ama equations of motion uba ukuthi yiphi kwamele uyisebenzise equation for finding the unknown. Okay, question 3 uphelela lana. Check out the description box for more content. Alright, for now ngizonishiya, guys. Ngizonibona second half. Bye bye.